I would like to welcome you all to IGLC28. So today I will present to you our paper on precast concrete building construction process comparison. The authors of this paper are Xiaosheng, who's a graduate student at the University of Alberta, and myself, Hamzeh. I'm an associate professor at the University of Alberta. The agenda for this presentation is we'll start with an introduction and we'll discuss the methodology, then we'll share the results and present the conclusion. As the introduction, as you all know that a lot of previous research on lean thinking has been published on improving the production systems to solve common problems. However, little research have been published on the precast concrete industry, which still suffers from long lead times, jumbled workflow, and a lot of process waste. And as we know, there's a lot of improvements that can go into the precast concrete industry. And not a lot of research actually have compared different processes from different countries, especially developing and developed countries. And this is what this paper tries to address. The methodology used for this paper is case study analysis. And in this, we have used case studies from two case studies, one from Canada and one from China, to compare the two processes. So the methodology that we have used is the following. We have chosen two cases, and both they do multifamily precast concrete construction projects. And those two projects we had access to information, and both of the projects we found out to be representative of the typical implementation methods at both countries. So the methodology was used is that we performed case study analysis, and we have done value stream mapping for the precast concrete method on both projects. And for that, we built current state maps for the two projects, and we have done a piecemeal comparison between the two. And then we developed future state maps for both projects. And then we combined the knowledge from this to come up with a far future ideal state map that can be applied to any precast project in the world. So first we start with case study one. The location is in Alberta, Canada. The project is a 6-story multifamily residential housing building. The precast supplier or precast contractor is a large local company, and this company is experienced in 3D modeling, and they use it in design. And they do themselves, they are engaged early on the project, and they do themselves design, shop drawing development, production, delivery, and they do on-site erection. So this is like the full range of the services. So what we have done value stream mapping for the project, and we have found out that there are some problems. For example, we found out although that they use 3D models for design and for shop drawing, what they have to do, they have to spend some time, between 5 minutes to 1.5 hours per drawing, to modify shop drawings out of the design. And we have found out that there's a lot of long lead time, from 1 to 2 weeks between production and delivery. And we found out that also before erection that the lead time is 1 month long. The second project is in Beijing, China. It's a 12-story multifamily residential building. The precast supplier in this case is also a large company, but what they do, they are a supplier and they have a subcontractor agreement with the contractor. So what they do in this case, they get the drawings from the contractors in 2D, and then they themselves produce the shop drawings, and then they produce the precast units, and they do the delivery while the contractor does the erection. Also, we've done value stream mapping for this process, for the local process, and what we have found out that there's a long lead time between the start of shop drawings because of the subcontract agreement. And we found out because they're using 2D traditional drawings, they need to spend around 2 to 8 hours per drawing because of they're starting everything from 2D. And what we found out also is that in terms of erection, on-site erection, the connection method requires in situ concrete to be poured between any two precast concrete members. So this actually also has some delays in erection. The comparison between the two processes, we found out that the involvement time in the project in Canada starts with early involvement, which gives earlier than the one in China. In terms of component designs, they have more standardization. And also the project in Canada has, they participate, the precast supplier participate early on, and you have the whole project life cycle view on that. While the project in China has superior in-house engineering because they do the shop drawings and all the design in-house. Now, what we came up with an improved process also for the for the project in Canada. And what we found out is that improvements can be by improving the cooperation, by having in-house design, by improving the shop drawing export from 3D, and by also introducing a supermarket and supply and production Kanban to actually reduce lead time. And for regards to the process in China, we also found out some improvements, which is applying BIM to reduce the design time, and actually to engage the precast supplier early on the project, and to have more standardized units to reduce cost. And also is that we came up with an ideal future state map for both projects in both countries, and this actual ideal future state map can be used by any project around the world. And these improvements included in them features from Industry 4.0 and technologies that are actually advised by Industry 4.0. So I'll share with you those Kaizen improvements. So first improvements is a combination between Lean and BIM methodologies to actually improve the production system. The second is to use data-driven simulation to inform project duration and cost, because right now all data we have on project duration and cost are unreliable. Another improvement is the use of RFID and other sensors to collect data throughout the value chain for better knowledge about supply and demand, and also life cycle management. The next improvement is to use within the facility, within the production facility, the use of autonomous vehicles to improve logistics and to reduce actually congestion and improve productivity. And also here we're suggesting to use an integrated system of technologies that use advised in the Industry 4.0, such as cyber-physical systems. Another improvement can be the use of virtual reality and augmented reality to educate and assess workers' skills, and at the same time to improve safety, to train them on safety. One Kaizen that applies to any process is to educate also students with reconstruction concepts to reduce the knowledge barrier, as Lean experts are critical to the success of Lean improvements for any precast supplier in the world. In conclusion, in this paper, we have compared two processes from two different countries in Canada and China, and we have found out that there is a lot of room for future improvement. The project in Canada, we found out, has less rework and shorter lead time that led to better productivity, and that can be attributed to the earlier involvement of a precast supplier company. Also, they have used BIM, and they have used a lot of standardization in their precast design and production. The project in China had a higher quality of shop drawings because of the in-house engineering capability. What we found is that there are room for improvement for both projects. So for the project in Canada, we advise to have enhanced cooperation and improved shop drawing export functions to reduce the design duration and shorten lead time. For the project in China, we advise to have BIM design capabilities and to involve the precast supplier early on in design. And to give feedback to any precast supplier in the world, we also came up with a comprehensive future state map that will utilize technologies in Industry 4.0, and we've laid out some ideas for how these technologies can be used to enhance the precast concrete industry in any country in the world. So with that, I will come to an end, and I want to thank you for listening, and we're looking forward to any questions you might have in the live discussions in July. Thank you so much. Have a good day.